Hello world! In today's tutorial, we're going to build a podcast prepper. Using CrewAI, Anthropic, and Exa, podcast preparation can be cut down from 4 hours to just 3 minutes, achieving a 98.75% reduction in time spent, all for approximately $0.13 in total. I'll show you an example in Python. Before we start, I want to emphasize that the purpose of my tutorials is not that you code parallel to me. For this matter, I always upload the full code to my GitHub profile. You can find a link in the description below. Let's get to the point. The podcast prepper is built using CrewAI Flows, which makes creating workflows super easy. You just run the command CrewAI create flow followed by the name of your flow. In my case, I named it podcast_prepper. CrewAI automatically sets up the folder structure for you. In the root directory, you'll find a crews folder, a tools folder, the main Python file, a read.me file, the pyproject.toml file, and a gitignore file. Inside the crews folder, there's an example called the poem crew to help us understand how flows work. Within the poem crew folder, you'll see a config folder, which holds YAML files for agents and tasks. Meanwhile, the tools folder contains the custom tool Python file. Now, let's dive into the code editor to understand what each file does. First, you'll notice there are more files here. Some of these were added later by me, while others were generated when I ran the flow. When you first run the flows command, you get the exact folder structure we saw in the CrewAI docs. Now, let's go through the entire project, file by file. I edited the read.me file created by the flow command to include all the relevant details about the podcast prepper. Initially, it only had information about CrewAI Flows. Now, let's take a look at the updated read.me file on GitHub, where it's nicely rendered. The problem we're solving today is the following Google Trends data for the search term podcast on YouTube shows a clear long-term rise in popularity worldwide since 2008. But according to a Reddit thread, podcast preparation can take hours. Some users even mention that prepping for a 10-minute interview takes 4 hours of research. Using CrewAI, Anthropic, and Exa, we can cut that preparation time from 4 hours to just 3 minutes and 98.75% reduction at a cost of around $0.13 per flow run. Keep in mind that costs vary depending on the flow run, and while I tried using a cheaper Anthropic LLM, the quality of the final report dropped noticeably. Let's go back to the code editor. I made some edits to the pyproject.toml file. Now we've got two commands, one for running the flow and one for plotting the flow. If you run poetry run plot, it will generate a workflow diagram for the podcast prepper in an HTML file. Let's go ahead and render that. Next, we'll open the main Python file, since this is where CrewAI plots the workflow from. At the top, we start with the imports. Then, we initialize the terminal output formatter to make the terminal outputs look nicer. After that, we set up the flow state using 3 variables: user input, CrewAI output, and token usage. Next, we move on to the class for the flow, where we pass the state. Inside this class is where the entire workflow is defined. The flow begins by greeting the user, which is indicated by the start decorator. Next, we listen to the say hello function, which is indicated by the listen decorator. So after the user is greeted, we prompt the user to enter guest's name and surname. If the user wants to quit the flow, they can do so. Also, the state is updated, more specifically the user input variable. Next, we listen to the getGuestName function, which is indicated by the listen decorator. So after the user enters the guest's name and surname, we kick off the guest research crew, passing along the guest saved in the state as input. When we get the response from the crew, we update the state, more specifically the CrewAI output variable and token usage variable, and display the response in the terminal. Next, we listen to the getInformationAboutGuest function, which is indicated by the listen decorator. So after we get information about the guest, we do 2 things. First, create a markdown file and save information about the guest. Second, create a text file and save information about token usage. Next, we listen to the save information about guest and token usage function indicated by the listen decorator. So after information about the guest and token usage is saved, we kick off the questions research crew, passing along the information about the guest saved in the state as input. When we get the response from the crew, we update the state, more specifically the CrewAI output variable and token usage variable, and display the response in the terminal. Next, we listen to the getQuestionsForGuest function indicated by the listen decorator. So after we get questions for the guest, we do 2 things. First, append questions for the guest to the previously created markdown file. Second, append information about token usage to the previously created text file. The flow ends by farewelling the user. We listen to the save questions for guest and token usage function, indicated by the listen decorator. So after questions for the guest and token usage is saved, we say goodbye to the user. At the bottom, we have two asynchronous functions, each triggered by specific poetry commands. When you run poetry run flow, it executes the main function, and when you run poetry run plot, it executes the plot function. Before we dive into agents, tasks, and tools, let's check out the env file. Here you'll need to set two environment variables, one for Anthropic and one for Exa. Both are API keys. All right, now let's dive into the agents, tasks, and tools. First, the guest research crew. In the agent's YAML file, we define one agent for this crew, the senior researcher, who will handle guest research. Then, in the tasks YAML file, we define one task for this crew, the research task, which performs the guest research and generates a report. We set up the entire crew in this Python file. After importing everything needed, we define the agent using the agent decorator, pulling configurations from the YAML file. For this agent, we specify Anthropic's Claude 3.5 Sonnet LLM, respect the LLM's context window, set it to iterate only once, display outputs in the terminal, and use Exa as a tool. Next, we define the task using the task decorator, pulling configurations from the YAML file. And we'll also enable human input to gather feedback. After that, we define the crew using the crew decorator, integrating both agents and tasks. We set the crew to run sequentially, write an output log file named in a specific format, and display outputs in the terminal. Second, the questions research crew. In the agent's YAML file, we define one agent for this crew, the senior journalist, who will handle question generation for the guest based on the previous crew's report. Then, in the tasks YAML file, we define one task for this crew, the journalism task, which performs the question generation and provides a list of questions for the guest. We set up the entire crew in this Python file. After importing everything needed, we define the agent using the agent decorator, pulling configurations from the YAML file. For this agent, we specify Anthropic's Claude 3.5 Sonnet LLM, respect the LLM's context window, set it to iterate only once, and display outputs in the terminal. Next, we define the task using the task decorator, pulling configurations from the YAML file. After that, we define the crew using the crew decorator, integrating both agents and tasks. We set the crew to run sequentially, write an output log file named in a specific format, and display outputs in the terminal. Lastly, Exa as a custom tool. After importing everything needed, including the Exa Python SDK, we define a class for Exa. We give it a name and a description. In this case, we'll use the search and contents function, which allow us to search the web and retrieve content for results. The query is set to the guest's name that the user enters in the terminal. The search type is specified as keyword, so you should only enter the guest's name and surname, no extra words. Exa will use this information as keywords for the web search, and we don't want anything else included. The auto prompt is set to false because we want to use the exact name and surname without any adjustments from Exa. The number of results is set to 10, which works well for ordinary individuals. For public figures, you might want to increase this number since their searches typically yield more relevant results. Let's jump to the browser for a moment. For ordinary individuals like myself, the first 10 results are usually the most relevant. After that, the results can become irrelevant, like a Slovene rock band that has nothing to do with me, except that the guitarist shares the same surname with me. Now, let's return to the code editor. Each result returns text, capped at 5,000 characters. Without this limit, some pages may contain massive amounts of text, which can be helpful if it's relevant to your guest. But if the content is off topic, it only increases costs without adding value. That's why setting this limit keeps things efficient. The summary is set to false since we already received the full text for each result. And the live crawl is set to always, ensuring we get the latest information for each search result. That's it. Let's run it. You'll find the link in the description below where you can read the README for full setup instructions. In short, clone the repository, change to the project directory, install dependencies, activate your virtual environment, and run the flow. After a brief setup, you'll be prompted to enter the guest's name and surname. For example, I'd enter my own name and surname here, but I won't hit enter since I've already done this. Instead, let's check out the log files together so you can see the full workflow in action from my previous run. The guest research crew was kicked off at this time. In just 3 minutes, it gathered all available information about the guest using Exa, since the Anthropic LLM doesn't have prior knowledge of personal details about me. Once the crew gathers data, you'll be prompted for human input. At this point, you can respond with feedback like remove the Facebook link if it mistakenly included someone with the same name, everything's fine, continue, or even I want a more detailed report. The crew will adjust its output based on your input. After that, the questions research crew was kicked off. In less than a minute, it generated 25 questions for the guest. Now, let's look at the final guest report, which includes sections on background, career milestones, online presence, achievements, personal life, influence, publications, current projects, philanthropy, controversies, awards, and sources. I use myself as the guest to gauge accuracy, and it's impressively on target. This is all thanks to CrewAI agents using Exa to enhance Anthropic LLM capabilities. When prompted for human input, I made minor adjustments, correcting the Twitter link to x.com, removing an incorrect Facebook link, and adding my YouTube channel. Even without these edits, the report was highly accurate. But if you're able to spend just 5 minutes on a quick search to provide social media links or other details, you'll get an exceptionally detailed report on the guest. And that's not all. Just look at the questions generated for the guest. Each one is thoughtful and prompts deep discussion. I could easily talk for minutes on each topic. What's mind-blowing is that some of these are questions I've genuinely pondered before. All this was achieved in just 3 minutes for roughly $0.13, which is a 98.75% reduction in podcast preparation time. If you're willing to invest another 5 minutes to give feedback when prompted, you can elevate the report quality even more. That's the real value of combining CrewAI, Anthropic, and Exa. Mind-blowing, isn't it? That's it. Thanks for watching. If this tutorial was helpful, please like, comment, and subscribe.